Alright, so in this video I'm going to be going over the midterm review part 2. So the first one here is from section 2.6, and that is dealing with solving radical equations, so equations that have radical expressions in them. So when you see an equation like this with a radical, and this one specifically is a square root, the first thing you want to do is to isolate the radical. So get it by itself on one side. So right now this whole thing is my radical. So I want to get rid of that negative x by doing the opposite operation. So I'm going to add x to both sides to cancel it on the left. So that will leave me with the square root of 145 plus 36x. Actually, let me write these steps on the left side this time. Equals 13 plus x. Okay, now the second step is to cancel the radical. By squaring both sides. So because this is a square root, anytime if I have anything, the square root of anything, and I square it, those two operations are inverses of each other, so they cancel each other's, and it'll just leave me with what's underneath the square root, which is x. So to cancel a square root, I just square it, raise it to the power of 2, but then I have to do that to the other side as well. So again, like I said, that will cancel that radical on the left, so it leaves me with what's underneath, which is 145 plus 36x. And on the right, this is 13 plus x, so I need all squared, so I need to FOIL it, because it's the same thing as this, multiplying that 13 plus x by itself. So now I will have to FOIL that right side. So I'm going to bring this down one more time. Okay, so for the first, that would be 13 times 13, which will give me 169. And then outer, 13 times x, which would be 13x. Inner, x times 13, which is again 13x. And then last would be x times x, which is x squared. So simplifying the right side, we combine the middle terms in the middle, which will give us a positive 26x. Bring down my x squared. And this is a quadratic because I have a variable squared as my highest exponent. So I'm going to start getting everything equal to 0. Because to solve a quadratic equation, you want to get it equal to 0. So I am going to subtract the 145 to both sides to cancel it here. And I'm going to subtract the 36x to both sides to cancel it there. So that'll leave me with 0 on the left-hand side. 169 minus 145 is 24. And 26x minus 36x is negative 10x. And then I'm going to bring down my plus x squared. Now I am going to rewrite this so that my x squared comes first, then my negative 10x, then my positive 24. So it's in that quadratic form. And now, because this is a quadratic, to solve it, I need to try and factor it. So let me move this over. So I need two numbers that multiply to give me 24 and add to give me negative 10. So that's going to be negative 6 and negative 4. So this will factor to x minus 6 times x minus 4. And so when I set each of these equal to 0, I get x is equal to 6 or x is equal to 4. Okay, now these are possible solutions. But just like with the rational equations, there's restrictions on these types of equations with radicals, because the expression underneath the radical here cannot be negative. And also we just need to check to see if it gave me a true statement, because when you square both sides of an equation, it actually adds extra solutions sometimes that may not be solutions to the original. So we need to check. We have to. There's no way around it. You have to check. So for x equals 6, we have the square root of 145 plus 36 times 6. And I'm just going to go ahead and set that equal to the 13 plus 6. So I'm kind of using the one after I added x to both sides. Okay, so plugging that into my calculator, 36 times, oops, okay, 145 plus 36 times 6. So this whole thing gives me 19 if you typed in this whole expression here in your calculator. So the square root of all that is just 19. So the square root leaves. And 13 plus 6 is also 19. So that one works. So x equals 6 is a solution. And for x equals 4, we have 145 plus 36 times 4 equals 13 plus 4. So plugging that in, I get 17 on the left side, and 13 plus 4 is also 17. So that one works as well. So my two solutions are x equals 6 and x equals 4. So you have to check your answers on radical equations. You just have to. All right, number 2. Consider the following equation of a circle. So we are moving into section 3.2 here. Okay, so the standard form of a circle that we are learning about right now in this section is x minus h squared plus y minus k squared equals r squared. So if you have an equation in this exact form, then the center of your circle, then this is a circle because you have an x squared and a y squared. That is what makes a circle. And whatever number is here and here, the h and the k, that is what gives my center. The center is equal to h comma k. And the radius is equal to r. So whatever number you have to square to get the number that this form is equal to, that is your r. So for example, this number 16, it's in this, first of all, this equation is in that form. So the number to the right, on the right side of the equal sign, is 16. So if you ask yourself, what number can I square to get 16, that would be 4. Because 16 is equal to 4 squared. So the radius is equal to 4, not 16. Okay, so you're just asking yourself, what times itself will give me that number? And that is how you find the radius. Now for the center, because both of these are already negative, like the general or the standard form, it is -6 and -5, just like this form here, because the standard form is -h and -k. So when these are also negative, then the h and the k are positive. So the center is just 6, 5. Notice how I didn't include negatives here when I wrote that the center was h, k. It's whatever number is being subtracted. So if that was positive, if it was +6 right here, then the answer would have been -6. So really you can think of it as it's always the opposite sign. So that is our center and the radius of our circle. So now we are going to graph this. So that was, the center was 6, 5. And the radius is 4. So first you're going to start with the center. So I'm going to go to the right 6. 1, 2, 3, 4, 5, 6. Right there. I'm going to go up 5. 1, 2, 3, 4, 5. And that will be my center right there at 6, 5. And then I use my radius of 4 to count outward 4 spaces from the center by going up, down, left, right. So if I go up, this would be right here. That's a point on the edge of my circle. If I go down, be right here. That's another point on the edge of my circle. Go to the right. That would be there, 4 spaces. And then to the left, 4 spaces of my center would be right here. So that is what my circle looks like with a radius of 4. Okay, number 3 says consider the following equation. So we are now moving into section 3.3, so more on linear equations. So I hope that this is a review from your previous classes or high school. But a linear equation is anything that has this form, ax plus by equals c. So if you have an x and a y, nothing is being squared. In fact, there's no other exponents but 1. That's how you know it's linear. And this question is asking us to find the x and the y intercepts if possible. So this is a linear equation. If I graphed it, it would make a line on the graph, and we graph things by using the x and y coordinate points, just like we kind of did with this circle, by finding the center point first. So we can always make like an x, y table to find points on a line by choosing values for x and then finding the corresponding y value. Now, if you have a line, let me just draw a picture real quick. You have an x-axis and your y-axis. The x-intercept is where a line crosses the x-axis, say like here. This is an x-intercept, the point where that line crosses the x-axis. And when we cross the x-axis, we are at y equals 0. So y equals 0 right here, because it lines up with the y value of 0. And for the y-intercept, where we cross the y-axis, x is equal to 0, because that point lines up with x equals to 0. So to find the x-intercept, I'm going to make an xy table. To find the x-intercept, we're going to let y equal 0. And to find the y-intercept, we're going to let x equal 0. So you're just doing the opposite. If you're finding the x-intercept, you're plugging 0 in for y. And if you're finding the y-intercept, you're plugging 0 in for x. Oops. Actually, let me do this. This is finding the x-intercept, and this is finding the y-intercept. Okay, now let's actually do that. So for the first one in green, that tells me to let y equal 0. So right here, I'm going to plug in 0 for y. And solve for x. And so 4 times 0 is just 0. That goes away, so that leaves me with 5x equals 30. Divide by 5. So x is equal to 6. 30 divided by 5 is 6. And so that means that 6 goes right there as the x-coordinate of that first point. So I just found the point 6, 0. And that's my x-intercept. And this was just an example, by the way. This is not the drawing of this line. This is just an example to show you what the x and the y intercepts are. Okay, and now we're going to plug 0 in for x. So 5 times 0 plus 4y equals 30. So I'm just plugging 0 in for that x, and now I'm going to solve for the y coordinate of that point. So 5 times 0 is 0. 4y equals 30 is what I have left. And then I will divide both sides by 4. So y will be equal, if I divide both of these by 2, that would be 15 over 2. So 15 halves. So that gave me the point 0, 15 over 2. And that is my y-intercept. Okay, now 15 over 2. 2 goes into 15 7 times with a remainder of 1. So that is equal to 7 1/2. Or 7.5 if you put that in your calculator. So I'm going to use that information to plot these 2 points. It says step 2, graph the equation by plotting the x and the y intercepts. So again, the x-intercept we just found is that 0.6, 0, and the y-intercept is 0, 7 1/2, or 7.5. So using this graph, if I count 6 over, that would be right here. So that is the point right there, 6, 0. That's my x-intercept. And then for the y, x is 0 and y is 7 1/2. 5, 6, 7. So that would be somewhere up here in between 7 and 8. So this was at 6. This is 7 and this is 8. So that's right in between 7 and 8. So that was my x-intercept. And this is my y-intercept. And then to finish graphing this line, I connect those 2 points. And then that's it. Okay, number 4 says to graph the line by plotting any 2 ordered pairs with integer value coordinates that satisfy the equation. So this is also, again, 3.3, just graphing lines. Notice that this equation only has one variable. There's no x. So whenever you have one variable, this is either going to give you a horizontal line or a vertical line, not a slanted line like we just seen in the previous example. This is a slanted line. So the best way to graph this is really to solve the equation for the variable. So if I divide both sides by 4, negative 4, sorry, then y would be equal to negative 2. So if I make an xy table, my y is always going to be negative 2, no matter what. It can't change because that says y is equal to negative 2. So if I said x is equal to 0, y is still negative 2. If I said x was equal to negative 5, y is still negative 2. It doesn't matter what x is. So you can pick any values you want for the x. The y value will just be negative 2 for all of them. So this is going to create a horizontal line, and in fact, y equals any number a is a horizontal line always. Horizontal line at y equals a, whatever a is. So this is at negative 2, so that would be negative 1, negative 2, 0, negative 2, that's that point right there. And then negative 5, negative 2, be right here. But again, it's just a horizontal line. I just used those 2 points I found right here. But you see that they both line up at y equals -2. So that's why it's a horizontal line. The y will never change. Y goes up and down. So if you're not going up or down, you're only going left or right. So that's the best way to graph that equation. And if it's x, x equals some number a, this is a vertical line, up and down, at x equals a. So these are just little notes you can have on your flashcard if you need them. Okay, number 5. Now we are in 3.4, which is still about linear equations, but we talk about some of the different types of forms of linear equations. So this one says find the slope of the line determined by the following equation. So to do this, we could put this in slope-intercept form, which is y equals mx plus b. This is called slope-intercept form, where m is the slope of the line, which is how much it rises and over how much it runs. It goes up and down over left and right. And b is the y-intercept, where it crosses the y-axis. So if you can get a linear equation to be solved for y, then you can automatically identify what the slope of the line is and what the y-intercept is. Okay, so that's what we're going to do. Step 1 is to solve for y. So I'm going to add x to cancel it on the left, but I need to do it to both sides, and that will leave me with -7y equals, now notice this, in this form, the x term is first with the variable x. So I'm going to write the positive x first, and then the -10, because that's the same thing as -10 plus x. Now I'm going to divide both sides by -7, which means I need to divide both of those by -7. Just divide everything by -7 to get y by itself. So that leaves me with y equals x over -7, or you could put the negative on the outside, it doesn't matter. Plus 10 over 7, because you have a negative divided by a negative here, which makes it a positive. Okay, so now we have y by itself. So to find the slope, you're trying to figure out what is the number being multiplied by the x in that first term. Well, that is going to be -1 over 7, because -x over 7 is the same thing as -1 over 7 times x. These mean the same thing. Okay, so the slope is -1 over 7. And the y-intercept, which it didn't ask us, is the 10 over 7. That's where the line would cross the y-axis. Okay, so now this is the slope of the line, which is all it asks us to find, but I just want to say that this means, remember, slope is equal to rise over run. So for this one, because the top is negative, You can make either one negative, it doesn't matter, but usually we just write the top number negative, -1. This would tell me to go down 1. And then the 7 on the bottom is how much I go left or right, and because I'm going to consider that as positive, that tells me to go right 7. So that's how you interpret the slope to go from one point to the next on a line when you're graphing it. Okay, number 6. We're moving into 3.5 now. So chapter 3 is a lot about, it's introducing you to graphs, but also it's a lot about linear equations. So it gives us this equation, 3x plus 5y equals 11. And step 1 wants us to express that equation in slope-intercept form. So if I have 3x plus 5y equals 11, slope-intercept form again means to solve for y, get y by itself. So I'm going to subtract 3x from both sides, which leaves me with 5y equals negative 3x plus 11. Remember, I'm going to write that x term first. And then divide both sides by 5. Just divide everything by 5. So y equals negative 3/5 x plus 11 over 5. Okay, so that was step 1. We got it in slope-intercept form because we got y by itself. So remember, this is slope-intercept form. So step 2 wants us to find the equation of the line which passes through the point -7, -2, and is parallel to the given line. So I'm going to write that equation of that line we just found. So I'll just copy this. Okay, so this is the given line that we just got in slope-intercept form. So I know what my slope is. My slope of this line is negative 3/5 because that's the number being multiplied in front of the x. Okay, so it wants me to find the equation of another line, a different line, that passes through this point, -7, -2, and is parallel to this line here. So when two lines are parallel, it means they never intersect, and it also means that they are rising and running at the same rate. So that means that they have the same slope. So parallel lines have the same slope. That's what we need to know here. Okay, so the slope of this new line that we are going to find is also going to be -3 over 5 because it'll have the same slope as that other line. Fix that. So I have the slope of this new line they want me to find an equation for, and I have a point on this new line that they want me to find an equation for. So anytime you're given a point and a slope to find the equation of a line, you're going to use the point-slope form of an equation of the line, which is y minus y1 equals the slope times x minus x1. This is point slope form, where x1 and y1 will be this point here that they gave me. X always comes first, so -7 would be my x1, which is what I would plug in here. And -2 would be my y1, which is what I would plug in here. And then the slope, which is m, is what I plug in for my m here. So that is how you find an equation of a line if you have a slope and a point on the line. So I'm going to plug this in, which will give me y minus, and then y1 is -2, so that's going to give me a double negative there, equals -3/5 times x minus a -7, which again is a double negative. So that's just me plugging that information into that point slope form. And now I will clean up these double negatives, which changes them to positive. So that will give me y plus 2 equals -3/5 times x plus 7. Now you can either distribute that fraction, or you can multiply everything by the denominator of 5 to cancel that fraction. So that's what I'm going to do, because I don't like to work with fractions. So I'm going to multiply all of this side by 5, and I'm going to multiply this whole side by 5. So on the left side, this I'll have to distribute, which will give me 5y plus 10. And on the right side, I only need to multiply the 5 by this first fraction because these two are being multiplied. So I don't want to keep multiplying it to everything because it's not a sum of terms right there. It's a product. So I only need to multiply that 5 by that fraction, which will cancel because 5 divided by 5 is 1, so that'll leave me with -3 times all of that. And so bringing this up here, 5y plus 10 equals, and then I'm going to distribute that -3 and get -3x minus 21. And they want me to express my answer in slope-intercept form, so that's why I'm continuing in this process, and I'm working on getting the y by itself. So I'm going to subtract this 10 over, which will leave me with -3x minus 31. And then I will divide everything by 5. So y will equal -3/5 x minus 31 over 5. So this is the equation of the line that is parallel to the other line. Notice they do have the same slope still, -3 over 5, but they will have different y-intercepts. But that's the final answer there. Okay, number 7. What was that one? 3.5. Yeah, that was, the one before was also 3.5. And this one is in 3.5. Section 3.5 is all about parallel perpendicular lines. So this problem, number 7, is going to give us 2 equations here of 2 different lines, and then we're going to have to determine whether they are parallel or perpendicular or neither. So step 1 wants me to express the first equation in slope-intercept form. So I'm going to take this, excuse me. equation here and rewrite it. And now I'm going to work on getting y by itself. So I'm going to distribute that 3 to get 6 minus 6x equals 7y plus 5. And then I'm going to subtract 5 from both sides. 6 minus 5 is 1, so that'll leave me with 1 minus 6x is equal to 7y. And then divide both sides by 7. Divide everything by 7. And I'm just going to rewrite it with the y on the left. So this is the same thing as y equals. And then I'm going to write the x term first. So that's negative 6 over 7 times x plus the 1 over 7. So that is slope-intercept form, which is what they wanted me to do for step 1. Step 2, we're going to do the same thing for the second equation. Get y by itself, so I'm going to add 3x to both sides. Negative 10 plus 3 will give me negative 7, so that'd be negative 7x. And then I'm going to divide both sides by negative 6 to finish getting y by itself. And then I'm going to rewrite it with the x term first. So that's negative 7 over negative 6, which is positive 7 over 6 times x, and then minus 1 over 6. So that is the second line in slope-intercept form. So number 3 wants me to determine if the two lines are perpendicular. So when you're determining whether two lines are perpendicular or parallel or neither, you need to look at their slope. So the slope of the first line up here, which I will call M1, is negative 6 over 7. And the slope of the second line is positive 7 over 6. So we need to compare these two slopes to see if these are perpendicular. Now, if two lines are perpendicular, then their slopes are negative reciprocals of each other. And negative reciprocals, some examples, if I had 3/2, then a negative reciprocal of this would be, it tells me to flip it upside down, which is the reciprocal of a fraction, so that'd be 2/3, and then multiply by a negative, so that'd make it negative 2/3. So it's like is it flipped upside down, and are they opposite signs? This is an example. Of negative reciprocals. And so if two lines have slopes that are negative reciprocals, then they are perpendicular. And if their slopes are the same, then they're parallel, like we just said. So these two are negative reciprocals of each other, because this one's negative 6 over 7. If I flipped that, 7 would be on top, 6 would be on bottom, and then this is positive. So these two lines are perpendicular, sorry. Okay, number 8. This is section 3.6. Sorry, so 3.6 is about linear inequalities now. So a little different than equations. So it wants me to graph the solution set of the following linear inequality. So we can graph this line starting as normal, like we would a regular line. So first step to graphing a linear inequality is to find 2 points or graph it using the slope-intercept form. So I'm going to graph it by using the point or the slope-intercept form. So I can go over how to do that. But you could also make an XY table and find 2 points. So first I'm going to solve for y. Now at this point I could just change this to an equal sign for right now. And just solve it like normal. So I'm going to subtract 4x to both sides, which will leave me with 2y is equal to negative 4x minus 12. And then I'm going to divide everything by 2. So y will be equal to negative 2x minus 6. Okay, so the y-intercept is negative 6. So that's 0, negative 6. This is right here. So to graph using the slope-intercept form, you graph the y-intercept first, which is where it would cross the y-axis, so at negative 6. And then the slope is negative 2. And I can make this a fraction by putting it over 1. So that tells me to go down 2, because it's negative, and then to the right 1. So if that was positive 2, I would go up 2 and then to the right 1. So I'm going to go down 2, 1, 2, and then to the right 1 from that point I plotted. So I went down 2 and then to the right 1 to find my other point. Okay, now I found my 2 points, and I'm going to connect these points to form a line, but you need to know if it's solid or dotted. So step 2, determine whether the line is solid or dotted. And that has to do with the inequality symbol up here. If it's strictly less than or strictly greater than, it can't equal the line. So that would be a dotted line. So this is going to be a dotted or dashed line. But if it was like this or like this, then these are solid lines. But if it's like this or this, then it's dotted or dashed. Because it can't equal. So we're signifying that it can't equal any points on this line. And I'd like to make this smaller so I have a little bit more room. Okay, and then the third thing we need to do is determine where we're going to shade. So when you have to graph an inequality, you need to determine whether it's solid or dotted. And then you need to determine which side of the line to shade. To do that, we're going to pick a test point on one side. So again, the side is either going to be this side of the line, this whole side that we will shade, or it'll be this side, because we're trying to shade which points make this inequality true. So I'm going to test the point. Now I can pick any point, but I'm going to pick 0, 0 here, because 0, 0 is usually an easy point to work with. So my x is 0, my y is 0. So I'm going to plug that into this inequality and see if it's a true statement. So 4 times 0 plus 2 times 0 is less than negative 12. So everything on the left would just be 0. And this says 0 is less than negative 12. Well, this is false. 0 is not less than negative 12. Negative 12 is less than 0. So because I chose this point here, and it was false, I'm not going to shade that side. I need to shade the other side. And so I would shade this side right here, and that would be my final answer. I'm going to stop this video now, and I will finish the rest.